Okay, now still under complex number, we are going to example 3. Now the quadratic equation is given here, and we are to solve for that one. In example 3, we have solve. Equation is 3x squared plus 4x plus 12 is equals to 0. So in our solution, we apply the quadratic formula. After applying the quadratic formula, we put the bracket to cover each letter separately here. Then we can substitute. After substituting for the values, where this one is A, this one is B, then this one is C, we just substitute them. After substituting, we simplify. After simplifying, we know inside the root here we have 16 minus 144. Yeah, 144. But before we reach here, we can start from here. It's being negative, x is equal to negative b plus or minus the square root of b squared minus 4ac, everything out of 2a. So that in the next step, we repeat the whole thing which is there, the expression, we repeat it here, but we put the bracket to cover each letter. Without any sign, we cover strictly letters. So that we substitute our b for this one. This b, our b is what? Is positive 4. So inside the bracket, we substitute positive 4. Even here, positive 4. And here we have negative 4. So our a is 3 according to this equation. It is here. We substitute here. So our c, which is a constant term, it is 12, which is a positive 12. We substitute here. Then denominator here is 3, which is a. We substitute. Then we simplify while opening the bracket also at the same time. So here we have negative times positive, we get negative, and will be negative 4. Here we have plus or minus the square root of 16 minus 144, because here 4 times 4, which is 4 squared, is the same as 16. Then negative 4 times positive 3, we get negative 12. Then negative 12 times positive 12, we get negative 144. So negative 144, and here we have 16. So 16 minus negative 144, we get negative 128. The denominator here is 6, we maintain the 6. Now, in the next step, we can separate this one. We have to get two factors, of which one of them we should be able to get the root easily. Meanwhile, the other one may resist the solution for us to get the root. So now in this one here, when we get two pairs of numbers, we get 64 and 2. Because 64 times negative 2, we get 128. So we can factorize like that one, so that 64 we know we can get the square root. So we shall use that one now. So while maintaining the rest now here, the root of 64. So then the next step, all of these we consider them separately. We deal with it, meanwhile maintaining those other things. We maintain this one and this one. So here, we have negative 4 plus or minus, then inside the bracket, root of 64 times negative 2 is the same as square root of 64 times square root of negative 2. So in this one, we get the square root of 64, we know it is 8. And the square root of negative 2, we maintain it. So that when you multiply 8 times 2, you get 8 root of negative 2. But since the root of negative, when inside the root here you are getting a negative, then it means it's a complex number. You have to find in form of complex number. So which means here, the square root of negative 2, we can do it side work near head. So here we are saying that square root of negative 2 is the same as square root of 2 times negative 1. Since we know that the square root of negative 1 is I, we must leave it aside to remain standalone. So here, 2 here, root 2 here, root 2 here, you cannot get the exact value, so we just maintain it. Meanwhile, we get the square root of negative 1, which is I. So here we have 2i. So since the root here, we are supposed to get the root of negative 2, so root of negative 2 we have got in the side work here as being 2i. So here we have root 2i. And now we can pull out the common factor to help us in reducing. There is no way we can pull a factor which can cancel this one completely. So what we do, we just reduce. When we pull out the common factor, we know that inside this 4 there is 2, inside this 8 there is 2, inside this 6 there is 2. So we can pull out the 2. After pulling out the 2, we cancel here. By 2 here 3. Then by 2 there will be 1. Then we remain with what in the bracket will be 2 and 4. But alternatively, since in between of 4 and 8 we have plus or minus, we can just cancel the denominator, because denominator is for this side and it is also for this side. We can just divide at once by dividing by 2 here 3, by 2 here 3, then the same 2 you divide by this one here to make it easy. So that is for that step. Then we can proceed in the next step. Yeah? And in the next step here, we come up here, which is we're going to get what we found from down here as being, the answer is going to be negative 2 plus or minus 4 root 2I out of 3. So the first value of x will take a positive sign in between. The next one will take a negative sign. So we can go ahead and say either x is equal to negative 2 plus 4 root 2I out of 3, or x is equal to 2 x is equal to negative 2 minus 4 root 2 out of 3, then all of them I. So that is the answer. So for that matter, you can also try the following. In our exercise, we are saying solve the following quadratic equation, giving their roots in the exact form. So part A, we have x squared minus 4x plus 5 is equal to 0. Next one is x squared minus 6x plus 13 is equal to 0. Then part C, we have x squared minus 8x plus 20 is equal to 0. Then lastly, we have x squared plus 10x plus 29 is equal to 0. So whenever you simplify what is in the root, then you find that inside the root you are getting negative number. Just know it is a complex number. I must be in your answer. But when you calculate and find that inside the root, what you are getting inside the root is a positive, just know you are going to get two answers which are not similar. But when you find what you have simplified in the root, it is a 0. Just know that it is a repeated root. You are going to have the same answer 2 times. If the answer is 4, you will get either x is equal to 4 or x is equal to 4. So that answer will be repeated, will be the repeated root. So what is inside the bracket there, we call it a discriminant. It helps you to identify what kind of roots are you going to get. Will it be real root? If it is a positive in the square root, it will be a real root. If it is a 0, after simplifying, you get a 0 inside the root, just know it will be a real root, but you will find that the answers are repeated. They are called repeated roots instead. So when you simplify what is in the root, you find that it is a negative. Just know it's a complex root. Letter I must appear in your answer. So thank you. If you have any question, you send us a message in the comment. But don't forget to like our page so that we can bring you more. Thank you so much.